Okay, so we go over the proof of derivatives of inverse trigonometric equations, and in this case, we focus on the derivative of sec inverse of u. Okay, so we were taught that the derivative of sec inverse of u, okay, is equals to u prime divided by absolute value of u multiplied by the square root of u squared plus 1, okay, or rather minus 1, sorry, minus 1. Okay, and we still follow the same steps. Our y, we let our y be equals to sec inverse of x, so meaning x is equals to sec y. Okay, so remember to say we need to find the derivative of we need to differentiate both sides of that. Okay, so with the fact that I believe you have watched the previous videos on the proof of derivative of inverse trigonometric equations, I believe you can pause the video, try to work it out, and see at the end if we are going to get the same thing. Okay, so here we say ddx of x equals to ddx of sec y, okay, sec y, as well as ddx of y itself. Okay, so what do we get? The derivative of x is 1. The derivative of sec y is sine y divided by uh, cos squared y, okay, multiplied by dy dx. Okay, so here what we have is our dy dx is equals to cos squared y divided by sine y. Okay, that's what we have. Okay, so these we can work with these very easily from the right angle triangle, unless if it was something like maybe sec itself, or maybe cosec or cot or something like that. But since you're dealing with sine and cos, we're able to work with that very easily. So it's just a matter of now us using the right angle triangle and see what we have. Okay, so the right angle triangle just helps us to make sure to say we have the hypotenuse, we have the opposite, and we have the adjacent, and we make sure to say we know what it is. Okay, so to say this is our opposite, this is our hypotenuse, and this is our adjacent, and our angle here is y. Okay, our angle here is y, like that. So now, before we even because we already have an x, we want to know where x is, and for us to know what x is, we have to understand what sec y is. And from trig identities, we are taught that sec y or sec theta, okay, is equals to sec y or sec theta is equals to 1 over cos y. Okay, 1 over cos y. So here where we have our x is equals to sec y. Okay, while there's sec y here, we're going to replace with what? 1 over cos y. Okay, here we're going to have 1 over um, cos y, like that. So meaning cos y is equals to 1 over what? 1 over x. Okay, so remember to say cos y or cos theta is equals to what? Adjacent over hypotenuse. So us having 1, okay, us having 1 over x, okay, us having 1 over x, meaning the adjacent is 1 and the hypotenuse is x. So here we have 1 and here we have what? We have x, like that. So what do we get now? of course we need to find the opposite in advance, and since we have the hypotenuse and we have the adjacent, we can find the opposite, because our opposite will be equals to what? The square root of the hypotenuse squared minus the adjacent squared. So what are we going to get? This will be x squared minus 1 squared, which is 1. So meaning here what we have is what? A square root of x squared minus 1, like that. So it looks like we have everything that we need to replace where there is cos y, cos squared y, as well as sin y. Okay, so starting with the numerator here, remember to say cos y or cos theta is equals to adjacent over hypotenuse. Okay, and remember to say we are talking about a squared like this here. Okay, so everything that I'm going to put in the brackets, I have to square it. So we're talking about cos squared y. Remember to say I'm talking about the numerator here is equals to the numerator, which is this one. Okay, is equals to adjacent over hypotenuse. Okay, what's our adjacent? Our adjacent is 1 divided by what's our hypotenuse is x squared. So what do we get? We get 1 over x squared. So here what we have is 1 over x squared over, remember to say we still have sin y on the denominator there, and we have to find out what it is as well. Okay, so sin y in this case is equals to the opposite over the hypotenuse. What's our opposite? Our opposite is this is square root of x squared minus 1. Okay, divide by what's our hypotenuse is our hypotenuse is x. So we come here and say we have something like this: x squared minus 1 divide by x, like that. Okay, and what we are going to have is that if you want to write this step by step, okay, if you want to find this step by step, I think let me just erase this. If you want to find this step by step, remember to say we have something like 1 over, okay, it tells us that we have 1 over x squared divided by the square root of x squared minus 1 divided by x. So meaning we can change this sign here and make it make it a multiplication sign, and we also change the numerator. The numerator will become the denominator, and the denominator will become the numerator. So meaning our denominator here was x, it becomes the numerator. Then the numerator was the square root of x squared minus 1 becomes the denominator. So x squared minus 1, like that. So we have an x. This x can go here, and this one can go. So meaning we are going to remain with what? Going to remain with 1 over x, then x squared minus what? Minus 1. So what we have at the end of the day is that the derivative, or dy dx is equals to what? 1 divided by x, the square root of, multiplied by the square root of what? X squared minus 1. When you look at this here, what we get here, this is the same as that. So here is more like you just got to put x here. X the derivative of x is 1. That's the one here. Here you just maintain it the way it is. We had an x, it's the x here. Then here is u squared, which is x squared here, then minus 1, and that's what we have here. So that's how you go about finding verifying the proof of the derivative of inverse trigonometric equation, in this case which is sec inverse. Thank you very much for watching.